Good morning, everybody. I hope you're having a great day. I can tell you I sure am, because today we've got a Codeforces round. Before we start, I want to wish everyone happy holidays. If you celebrate Christmas, congratulations. If you don't, you have my sincerest condolences. But if you celebrate anything else, you can always get a Christmas wreath and Christmas lights anyway. Maybe a Christmas tree too, if you want. But anyway, today we have a Codeforces round. So it's Codeforces round 690, Div 3. I'm a little bit late to it. I think there are probably already a whole bunch of solves, I would guess. Yeah, here we go, lots of solves. So we'll jump into it in just a moment. And before we start, I changed my sort method back to ruffle sort. It used to just be sort using collection stat sort. This is ruffle sort, so it does a random ruffle first, shuffles the array around, and then it calls array.sort. This makes it n log n. So I've talked about this quite a bit, but arrays.sort can be n squared because there's some cases where you pick the wrong pivot every time because this uses quicksort. So to avoid that, we can shuffle the array, and that way we don't pick like bad pivots every time. All right, now I'm going to start the contest in just a moment. At the end of the contest, I'll have solutions to all of the problems. So you can skip to that if you're interested, and then you can see solutions to whatever you didn't solve in contest, or you can see like my solutions to see if they're different. And I guess last thing, this is going to be my last contest with this subscribe to Galen Collin message. So definitely check out his YouTube channel. I lost to him in a lockout duel. So yeah, so there you go. Check him out. He's definitely good. All right, on to the Div 3. Problem A. Favorite sequence. Polycarp has a sequence consisting of n integers. He wrote it out on a whiteboard as follows. He wrote A1 on the left side, then he wrote A2 to the right of that. Oh, to the right side. Then A3, okay. He continued to act until the entire sequence was on the whiteboard. Writes this, okay. Now, you saw the sequence written in the whiteboard and want to restore Polycarp's favorite sequence. So 3, 1, 4, 1, 5, yeah, okay. Int n equals this, int l equals 0, r equals n minus 1, array a equals read array of size n, while l is less than or equal to r. Boolean left equals true, then left XOR equals true. So now if left sys out a at l and I guess a at l plus plus really, and then otherwise sys out a at r minus minus. Then we keep swapping sides, and then I think that should be it, except we want these to stay separated. And then we want a new line between test cases. Very good. Oh, and I just ruined my template class. But that's fine. Okay, so let's submit this. Alright, so now this is A. The template, we want just this. And we got it. Good. Alright, on to problem B. Last year's substring. Polycarp has a string of length n decimal digits. He performs the following operation in the string no more than once. He can perform 0 or 1 times. Select 2 numbers, remove the characters from the string at those positions, between those positions. So you're going to wind up with a prefix and a suffix. He likes the string 2020 very much, so he was wondering if it was possible for him to turn the string s into a string 2020 in no more than one operation. 20, 20. Yep, very easy. Okay. Let's go. Alright, so now if its length, okay, its length is at least 4, 4 int l equals 0, l less than or equal to 4, l plus plus. Yeah, 4 forint to check equals 0, to check is less than L, check plus. So if target it to check is not equal to line it to check, then we can't have this many things in the beginning. We continue outer. Okay, forint to check equals 0, to check is less than 4 minus L, check plus plus. If target n minus 1 minus to check is not equal to line at 4 minus, or I guess, yeah, 4 minus 1 minus to check, then continue outer. Otherwise this out, yes. Continue test, otherwise this out, no. Index 7, line at 4 minus 1 minus to check. So this part is fine. On this first case, presumably. Oh, I've got these mixed up. This should be line. This should be target. All right. 200 test cases, so we should be good. Awesome. Took longer than it should have probably, but we can keep going. On to problem C. Unless we get it wrong. All right, we got it. Nice, nice. Given a positive integer n, find the smallest positive integer that has the sum of digits equal to x and all digits are distinct. So 9, 8, or I guess, yeah, 9, 8, 7, 6, 5, and then sort the digits at the end. The biggest it can be will be 10 times 5, 10 times 9 over 2, right? Oh, -1 otherwise. Okay, so now array list, integer list, array list, and then for int I equals list size -1 greater than or equal to 0 minus sys out list I get I, and then a new line. Okay, so then we need to make this int max equals 9 while n is not equal to 0. List.add math.min max and n, and minus equals max. Max minus. I think we're fine there. Oh, don't sort it. I'm putting it backwards. All right, good. We should probably try 45 as well. Yeah, okay. Good. Submit problem C. Good. On to problem D. Add to neighbor and remove. Polycarp was given an array of n integers and can perform the following operation n times. Select an index, add the value of a of I to one of his choice of neighbors. After adding it, Polycarp removes the ith element from the array. If the neighbor does not exist, it is impossible to add to it. Okay? Then remove it from the array. During this step, the length of the array is decreased by 1. The two items together denote a single operation. Because this array, you can perform the following operations. So add 6 to the previous. Yeah, okay. He selects I equals 1, adds the value AI to the AIth plus 1 element. I think they mean I equals 2 here, I hope. Oh, we're doing, this is one step after, okay. Selects the value this and adds it to this. Okay, got it. Then he selects index 3 and adds it to this. Yeah, okay. Polycarp can stop performing these operations at any time. What is the minimum number of operations you would need to make all of the elements equal? So he can always do it in n steps. You have continuous ranges that sum to the same thing, right? So yeah. Once you know what the first thing is, that'll tell you what the sum is, so then you just wait till the sum is that. You probably want the smallest thing in which it's true. That'll always be the best. So yeah, brute force the size of the prefix and then try however it works. We can implement that real quick. Int n equals this, array a, read array size n, int prefix size, well, okay, this times this is 3 times 10 to the 8. That's fine. Alright, so we want to keep going till we get to the end of the array. So while I is not equal to n, yeah, I think this is fine. And then if this all works, then we're fine. Okay, so otherwise we can say sys out the number of operations. No, it matters to 2. Okay. Sum equals 0 or equals 8i. Well, I is less than n, and sum is less than prefix value. I plus 1 is less than n, maybe? Yeah, okay. Then sum plus equals a at I plus 1, I plus plus. If sum is not equal to prefix value for whatever reason, then we're in trouble. So then continue other. And I think this handles all of the cases. Oh, not equal to n minus 1, I guess. This should be less than or equal to prefix size, probably. Otherwise, I plus plus. Well, okay, let's do this. So 1 less than or equal to n goes to prefix, or starts at prefix size. This should be less than prefix size then. All right, so then sum starts at ai, starts at prefix size, yep. And then increment I otherwise. This should be I is less than n. And then, yeah, I think we're good. Okay. Not even close. What is going on? Why do we print multiple things per? Okay, then this should be break. This should also be n ops plus plus. 0, 0, 2. 0, 1, 0, 2. Okay. What? Prefix size 1, sum of 1, sum of 2. What on earth? Oh, yeah, so this starts with pref size minus 1. Good. Yep, alright, cool. Gotta make sure the subscribe to Galen Collin message is good. Yeah, alright, cool. We're going pretty slowly here, but that's fine. Yeah. Let's read, I guess we'll read both of them, but here we go. This is the easy version of the problem. The only difference between the easy and hard versions are the constraints on k and m. In this version, k equals 2, m equals 3. Also, in this version, you don't need to print the answer by mod. You can only make x if both versions are solved. You're given a sequence of n integers from 1 to n. The sequence may contain duplicates. Find the number of tuples of m equals 3 elements such that the maximum number in the tuple differs from the minimum by no more than 2. So how many groups are there of things that differ by no more than 2? So we want to pick 3 things. So we can pick 1, 2, 3, or 2, 3, 4. Here we can pick, well, there are 3 different things we can pick, right? Or 4, because we can exclude any one of these. There aren't 3. Yeah, okay. Sounds like n choose k. Yep. So this is just the same problem, right? But you print under mod, okay? And they differ by at most k. Yeah, I think this is pretty easy. So I guess I'll explain it at the end. So if you want to know the idea behind what I'm doing here, you can, well, no, I'll explain it now. Never mind. Yeah, here we go. So here's the idea. We need just a new whiteboard. There's too much stuff on that whiteboard. Okay. So the idea is that if you have a bunch of numbers, right? So here are your 1s, here are the 2s, here are the 3s, 4s, etc. Then we're interested in the things in like this range, for instance, for the easier version of the problem, but like this size isn't really important. So what matters to us is the number of things here, and then we're going to pick k of them, but we don't want to double count this. So like if all of the things in here are 3s and 4s, we don't want to count like some pair of things that are 3s and 4s here, and then also count that same pair when we're considering 3s, 4s, and 5s. So we need to brute force what the biggest thing is. In this case, we'll say we can guarantee the biggest thing is right here, is this 4s thing. So yeah, so we'll do that. And that means we're really picking k minus 1 things, and the number of things we have in this range is really however many 4s we have minus 1, assuming that we have at least 1 4. So yeah, that's the math. So it's going to be like if we have n things in this range, there are n things here, we pick k, so it's going to be n minus 1, choose k minus 1. We'd figure out how many things we have in this range just with cumulative sums, I think. Yep. That's it. So I guess this is div 3, so let's do the math here. N minus 1 choose k minus 1. Well, we'll just talk about n choose k, right? So this is what we'll really be doing. But if we want to calculate n choose k, there is math that says this is equal to n factorial over k factorial times n minus k factorial. So in other words, if you have like a bunch of balls, you can order the balls in n factorial ways, and that's, you want to split the first k from the last k, but we've just overcounted a bunch because you can reorder any of the first balls and you'll still have the same first k elements. You can also reorder the last n minus k balls and still have the first k elements be the same. So that's where this formula comes from. Okay, we can pre-comp these factorials because n and n minus k are both under 10 to the 5th, I think. 2 times 10 to the 5th here. And we can do this division using mod inverses. So I did an algorithms thread video on mod inverses. And if you're interested in that, you can watch that video. And I won't talk about too much of it here. But yeah, let's do that. That's problem E. We need a bunch of stuff. So we need static long the mod, static long multiply, we probably need, do we need to add? Do we need to add things? I don't think we need to add stuff. Okay, so now we need the factorials. So static long pre-comp. We're gonna have a static long array facts, new long array this big, facts is new long array, or facts at 0 equals 1. And then int I equals 1, I is less than facts.length, I plus plus. Facts at I equals multiply facts at I by I, or facts at I minus 1 by I. Cool. So there's that. Then we need inverse, static long x. So whatever base to the power is equal to 0, return 1. Base to the power over 2. If pow mod 2 to 0, return multiply the half by the half. Otherwise return half by half times the base. Okay, this should be void. What was I thinking? And then we need to call it in the beginning. Then we need mod inverse. Okay, so return the x to the mod minus 2. That'll be our mod inverse. And then static long n choose k. Or I guess int n, int k. Return multiply facts at n times multiply the mod inverse of facts at k times the mod inverse of facts at n minus k. Good. All right, we got lots of stuff done. So then we just need to read an input, n, m, and k. So k is how many, wait, what is the, yeah, m is the size of the tuple, k is the maximum difference. So just increment this position. All right, very good. And then, oh, so this is counting sort. We also want this to be cumulative sum on counting sort. For int I equals 1 less than cs dot length I plus plus. Yeah, we'll just call this frequency. All right, good. And now for int, well, okay, so this is the long ways equals 0. We do want to add. Static long add, long a, long b, return a plus b under mod. Okay, for int the max equals 0, max less than frequency dot length, max plus plus. Frequency at max equals 0, then continue. Because we can't have this actually be whatever the maximum is. Okay. Otherwise, int n less than equals cs at max plus 1 minus cs at math.max 0 max minus m. You can differ by at most m, right? No more than m. Yep, okay, now ways plus equals, okay, so if n less than, it's less than k, continue. Otherwise, ways plus equals, n choose k, we have n less than minus 1, choose k minus 1. K can be 1. So I'm not totally right here, actually. Yeah, this isn't right. So here's the thing. So we've got like some of these, then some of these, and then some of these. If we want to pick maybe 2 elements, all right, I'll be right back. Alright, the idea here. Well, first of all, what was the problem? The problem was that we were saying we're always going to pick this biggest thing, no matter what it is. But we don't have to have this be the maximum. The maximum can be any one of these three. And we're not like brute forcing it or anything. So that would be a good thing to do. So if we brute force what the maximum is, then we'll handle that case. Which essentially means, like, if this is the maximum, we just aren't allowed to pick these two items, and then we have to pick k items from these, not including this one. Alright, so the number less than will be this. Let's not include this. 4 into include, 0 to include is less than frequency at max. Okay, otherwise, ways plus equals. What are we adding here? So number of less than plus to include minus 1, and then choose k minus 1 because we have to pick the biggest one. Then sys out ways. Not even close. Okay, why is that? Let's just do this one case first. Max 2 adding 1. That is not right. If number less than, oh, this should be frequency. No, it should be CS. And this should be frequency. So this should be k. So I have my variables backwards, and then this should also be k. Alright, are we fine now? Yeah, good. Alright. Nope. Ways equals add, ways to add. And I think we're fine. Good. How many test cases? Lots of test cases. Okay, so print writer. I'm just making a joke here with this. Don't take it too seriously, you know. Just a pun. Good. Should have submitted to E1 first, but oh well. Okay, doesn't matter. We should almost certainly get that one right then too, and that means we're on to this problem F. What? Does it have different input? Okay, hang on. M equals 3 and K equals 2. Wait, what was M is the number of elements. So this should be 3, range size is 2. Okay. Submit. I don't know if this counts as breaking my wrong answer streak or not. Oh, it did. Okay. Hang on. That's also, that's trouble. Wait, is it troubled because we're printing it under mod? So how big can this get? Wait a minute. Okay, this is very sketchy. This is very sketchy. What? Oh, because we're only picking 3. Got it. But it can get up to n times, or n cubed. Okay. All right. Mod equals. Oh wait. This is a problem. Come on. Are they really gonna? That's so obnoxious. Why would they not just have a mod for this problem? Why no mod? Okay. We could just do it with 2 mods, then use Chinese remainder theorem. So the problem here is that I want to use mod inverses, but I can't use mod inverses if my mod gets too big, because and they don't want me to print it under mod. So I think like one way of doing it is just to do it under 2 different mods, then use Chinese remainder theorem to get the answer. It's also just n choose 2, right? This n choose k thing. How big is k? K is 3, so it's always n choose 2. Okay, so we can get rid of this. Don't need factorials. I don't think we need multiply anymore. We don't need pre-comp. We don't need add. We don't need exponent. We don't need mod inverse. We don't need n choose k. Yeah, okay. Wait, ooh, that's a problem. I think that's my only multiply, so I should be fine. Yeah, do I have a long here? I do. Okay. So that did break my wrong answer streak, unfortunately, but that's fine. All right. Problem F, last one. Polycarp found n segments on the street. A segment with index I is described by two integers from Li to Ri. Polycarp realized he didn't need all the segments, so he wanted to delete some of them. Polycarp believes that a set of k segments is good if there is a segment such that it intersects every segment from the set. The intersection must be a point or segment. For instance, 3 segments blah 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 is good, since the segment 2, 3 intersects each of them from the set. A set of 4 segments 1, 2, 2, 3, 3, 5, 4, 5 is not good. What is the minimum number of segments he has to delete so that the remaining segments form a good set? This is just how many segments does each segment intersect, right? Because you pick one segment, then you use that one as the main one. Okay. It sounds pretty easy to me. Yeah. So we want to know how many segments does each segment intersect. So we're gonna go from left to right. I think we can do a segment tree probably. So we've got a bunch of segments like this. When we see this, we subtract one here, and then we add one to our counter. And then when we see this, we, oh, I guess we add one here. Yeah. Well, we'll process this at the end then, maybe. Or no, it's fine. We can add one here. So then when we see some segment, maybe, well, okay, so we add, okay, so then minus plus. So then when we see some segment like this, we want the sum of all of these. We just care about the start point. Yeah, we don't need to worry about these minuses even. So there's one here. We intersect one here. We intersect one here. That's not entirely true. What am I saying? Okay, this should be an easy problem though. The question is just how many segments does each segment intersect? So, yeah. So if we sort them by right endpoint, then we've got some segment. We have some segment here. We care about all of the segments we've already processed whose left endpoint we can reach. And also we care about all the segments after us who have already started but haven't finished. So these all need to be pluses. These also need to be pluses. We could just put these here though, and then do a range sum like that. Okay, yeah, that's the solution. Okay, so then, good, so we just need a bit. What am I doing? Okay, F. Oh, did I already make an F? What is this F here? This is E2 really. And this one is F. All right, so we need a Fenwick tree. What do I want? UCF Hackpack. GitHub has dark mode now, by the way. If you're not very excited about that, you should be. You can go to your profile and then you can switch to dark mode. It's very, very slick, I think. All right, so we have this Fenwick tree. This formatting is ugly, man. Much better, okay. And yeah, so now we need some events. So int x1 and an x2. Two things can start at the same x1, and they will intersect. Yeah, that's fine. Oh, what is this? This is okay, Boolean start. Okay, good. So now we have all of these segments, int n equals this. How big coordinates? Up to 10 to the 9. Okay, we should probably coordinate compress then. Yeah, that's fine. Okay, static class segment, int L, int R. So we want to add this s.l and then also s.r. Then hash map integer to integer compress new hash map. So we can coordinate compress all these things. Then for int I and x's compress dot put this thing to compress dot size. Now for seg for each segment, s.l equals compress dot get s.l. Same thing with the right endpoints. All right, so now we've compressed everything. good. Bit, new bit, compress.size, +1, I guess, I don't know, whatever. And then we want to do range sum. So we've got query from LDR, good. Right. So we've got these two events, or wait, we already made this. So now index equals 0 for seg s and segs. Events at s dot, or at index plus is new event. All right, so the events, if they are a start into x, so if start, return x1, otherwise return x2. This is kind of hard to explain. So the start events will be when we add 1 to the end position, and then the end events will be when we process this range. Like when we find the sum in this range. Okay, hopefully that makes sense. So this will be a new event from s.l to s.r. This will be a start event. Then we'll also make a end event. Arrays.sort events, and then for event e end events. So if this is a start event, then we want to say bit.update e.x2 by 1. Otherwise, the candidate answer will be bit.range or bit.query from e.x1 to the end of the array, which is compress.size. Ans equals 0. Ans equals math.max. Ants and can +1. And then, well, we'll include ourself actually, right? So it's just canned. So then sys out the answer. Nope, not even close. Okay. There's 0 good segments. Oh, minimum number that need to be deleted. So this will be minus ants. 0, 1, 2, 0. Okay, I think that's right. Do we need print writer? We do. Lots of test cases. Good. I think we're fine there. Any way to clean this up a bit? I don't know. It's fine. Let's run this one more time just to sanity check ourselves. 0, 1, 2, 0. Submit problem F, and here we go. Wrong answer test 2. Okay. Why would that be? Really, wrong answer test 2. That's the problem right there. Yeah. Okay. If x is not equal to o dot x, then return this. Otherwise, if start equals o dot start, return 0. Otherwise, if start, then you want to process me first. Return -1. Yeah, okay, so let me try what this was before to break it. So if we had, break case would be one test case, two things from 0 or from 1, 2, and then 2, 3. The answer here would be 0. Why would that be? Should be getting it wrong, I think. Oh, yeah. Okay, so let's do 3 then. The answer is 0, so if I fix this, then it'll be 0. Alright, beginner mistake. That's why we practice on some div 3s once in a while, right? Alright, cool. So there's a set. I didn't do well. Yeah, not great. But solve set. Let's go over solutions real quick. Yeah, sounds like a plan. All right, solution time. So how do you do each of these problems? Okay, so problem A, favorite sequence, is pretty much just straight implementation. So you just look at the first thing, second last thing, third last thing, all the way up until you are done. And that's the answer. So there are a bunch of different ways to implement that. The way that I chose was I have like this left pointer and the right pointer, and I also store whether I'm looking at the left side or the right side. And then every step, as long as my left pointer and right pointer haven't crossed each other yet, then if I'm looking at the left side, I move left pointer over 1 with this L++, and I read the thing that was where it was before I moved it. And then otherwise look at the right pointer, move the right pointer over 1. So just if you're not familiar with this, this is the same as this code. So if that scared you. This thing just flips the value of a Boolean. So XOR equals true. If it's true, it'll make it false. If it's false, it'll make it true. So this flips it. It's the same as like left equals not left, if that's easier for you to read. So yeah, this is the solution to problem A. Hopefully that's pretty easy. Shouldn't be too much trouble there. Last year's substring. Yeah, okay, so this one, you want to remove some continuous range in the middle. And the important thing to notice there is if you have a bunch of letters, and you remove some stuff in the middle, what you're left with is a prefix and then a suffix. So you want these two things together to be 2020. You want them to say 2020. There are a bunch of ways that could do that. You could have 2020 all at the end. You could have a 2 here and then a 0, 2, 0 here. You could have a 2, 0 and then 2, 0. I guess we'll just do all the ways. Then you could have 2, 0, 2 and then a 0, or you could have 2, 0, 2, 0 and then nothing. So you've got these 5 ways. This is 1, 2, 3, 4, 5. You can either hard code all of these. That's one way you can do it. Or alternatively, if you don't want to do that, then you can use a for loop. So you can check however much, or like the size of this prefix. So here, this is 0, this is 1, 2, 3, and 4. And then you can check if the first that many letters match the first that many letters of 2020, and then the rest of the letters match at the end. So what does the implementation look like for that? Target is just this array 2020, and then I do a order length of target times length of this line to check. So I check like L is the length of the side that's going to be on the left, And then I check that the first that many things match, and also the last that many things match. Or the last 4 minus that many things match. If they all do match, then the answer is yes, there's a way of doing it. And if any of them don't, the answer is no. Or if all of them don't, rather, the answer is no. So yeah, that's the idea for problem B. Pretty easy again, just implementation. Problem C, unique number. So you have to find the smallest positive integer so that the sum of digits will be equal to x and all digits are distinct. So the first thing to notice is that if you want the integer to be smaller, you want the digits to be in increasing order, right? There's no reason to use 0, first of all. But then after, you're not going to use 0 because 0 doesn't add to the sum. You want the sum of digits to be as big as possible. So for like the same number of digits. You also want them to be sorted because the digits that are like the more significant digits will matter more, which means you want them to be smaller if possible. So once you have your number, if you know which like digits you're going to use, then you wind up sorting the rest of it. Basically, what you can do here is just use a greedy. So the idea behind the greedy is, we'll skip this 45 part for a minute. You start by placing a 9 in the ones column, and then you can't place a 9 anymore, so the biggest thing you can place is an 8, and then a 7, 6, 5. So you keep placing the biggest thing you can until you only need one more number, right? Until you go past wherever you're looking for. And at that point, you just place whatever number you need to. So we can do an example here. Let's say your target is going to be, your target sum is 18. So the first number you place is a 9. That's the biggest you can place. Now your target is a 9. Now the biggest number you can place is an 8, so you place an 8. Now your target number is 1. Now the biggest thing you can place is a 7, but 7 would be too big, so you just place a 1. This is going to be your optimal answer. The reason for that is because we want it to have the fewest number of digits possible, which it does, because we placed the biggest thing we could at each turn. You also want this first number to be as small as possible, which it is, because these numbers are as big as possible. So there you go. It's also sorted. So it follows all of the constraints that we were looking for, which means 189 is the smallest number whose digits sum to 18, where all the digits are different. Okay, awesome. That is the solution there. The other thing to watch out for is if you, like the biggest number you could have obviously is 1 plus 2 plus 3 all the way up to 9, and that adds up to 45. So you can print -1 if it's bigger than 45. There you go. You could also print -1 if like this doesn't work out after your while loop, whatever you're looking for. Okay, cool. Problem D, add to neighbor and remove. So in this problem, you have an array, and you can like combine two elements into one, where their new value is going to be their sum. So specifically, they say you add the value to an adjacent one and then remove yourself, but really you're just combining those two elements, two adjacent elements. In this problem, I guess that's a bad example. Let's look at a better example maybe. So yeah, okay. So you can do 1, 1, 2, 2, 1. So in this problem, you can combine these two into a 3, combine these two into a 3, and now everything is the same. Now there might be a better way of doing this problem, I'm not really sure, but they give you really small bounds. So since n is so small, you can do an n squared, and the n squared is very easy. So I'll just talk about how to do the n squared. Yeah, it might be possible to do better, I'm not really sure. But here's how you do the n squared. So the first thing to notice is the numbers that you create at the end will all be equal to some continuous range in the initial array, and they'll all be like disjoint continuous ranges that make the entire array. So basically what you're going to do, like all you're doing here, is taking your initial array, splitting it up into sections where each section has the same sum, and then combining each section together. So that's really what we're doing. Now, if we knew what the sum of a section would be, then we can very easily say how to do it. So if we know the sum of each section is going to be 3, then we can just say, okay, keep including elements from the beginning until we reach a sum of 3, and then create a new section. And then keep creating elements till we reach a sum of 3, and then create a new section. If we ever go from a sum of like 2 to a sum of 4, for instance, then we know 3 isn't a valid answer because we haven't made any smart decisions here. It's like we can't make the wrong decision. So if we ever go from 2 to 4, that means 3 doesn't work. So yeah, that's the idea. So how do we find what things to brute force? Well, there are only n choices for what the first section can have the sum of, because it has to be some prefix, right? So we brute force what this first section is. When we know the sum of the first section, we know all sections have to have the same sum. So whatever that first section sum is, that's going to be the sum of the rest of the sections. And we can check whether that works in linear time. We want the smallest thing that works because that will require the fewest merges. Or you can try all of them if you want. Like, you don't really have to make that observation even. But yeah, so we want to brute force what this first section sum is going to be. Then we walk through the entire array to see if that works. In code, what that looks like is this. So this prefix size is going to be the size of the first section, the number of things in it. And I find the sum of the first this many things right here. And then after that, I walk through the rest of the array, and I make sure that splits up nicely into sections with the same sum, with the same pref sum. So specifically, I get like this I is like the start of the next section. Initially, the sum starts at that, and I keep expanding it as long as I'm not at the end of the array and I can't expand it. And then if the sum doesn't, or yeah, as long as like the sum is too small and I'm not at the end of the array, I keep increasing the size of that section. Then finally, either I'll hit the end of the array and the sum will be too small, or I'll take one step, I'll include the next thing, and that'll put me over where I need to be. That'll make the sum bigger than this prefix. So if that's the case, then it's also impossible. So either way, I want to like ignore that case, or I want to say that like this isn't going to work. So then I continue out of this for loop, and that's the idea. Yeah, if it works for all the sections, then I just print however many operations I did, which is however many things were joined together. So here I joined 2 things together from the same section, and here initially you join the first like section size minus 1 things together. Yeah, so that's problem D. All right, 2 more problems, E and F. Problem E is, yeah, so there are 2 parts to this. I'm going to talk about just E2 because I think E2 and E1 are basically the same. But yeah, you can use the same reasoning for E1 if you'd like. So the idea is we want to say how many continuous, or how many groups of M numbers are there so that the difference between the biggest and the smallest is equal to K. We can also have duplicates of a number, so those count. So how many groups of like N or M things are there where the difference between the biggest and the smallest is at most K? So here's what we can do. We can like draw out some pictures here. Let's have these numbers sorted by value. That might be helpful. It can't hurt anyway. And I'm going to put a space here when the values change. So let's say we have 4 different values, and then we want the maximum difference between 2 things in a set equal to, we'll say 2. So one example set that we could use is we could pick this element, and this element. That's one possible choice. Another choice is we could pick this element and these 2 elements. And here, the biggest one here would be 1 bigger than this one here. Okay, so here's the idea. Let's say we know what the biggest thing in the set is. So each of these things are ordered from left to right, which means the bigger things will be at the right. So let's say we know what the rightmost element in the set is. Maybe it's this thing right here. That means since we know this is the biggest one, we know 2 things. 1, we have to include this element, and 2, we're not allowed to include any of these elements in the set. Also, since we know this is the biggest element, we know the rest of the things we have to pick from are the things in this range here. We can't pick any of these things because then the difference between the biggest and smallest will be too big. It'll be bigger than 2. So if we're picking, let's say we're picking m equals 3 things, then the number of ways to do it, if this is the biggest thing in the set that we pick, is just this 6 things, choose 2, right? Because we're forced to pick this, we have to pick 2 more things, and those 2 things will be in this group here. So it's 6, choose 2. We can figure out how many things are in this group with a couple methods. We can use either a 2-pointer sweep, or we can use cumulative sums. Personally, I used cumulative sums because I thought they were just easier, but you can do whatever. And specifically, you want to see how many things are there that are less than this, but within the valid range if you pick this. So between this and this minus k, I think. Inclusive, exclusive, just be careful. Do an example on paper and make sure it works out. So if we know how many things there are there, then we can see how many, or what this numerator should be. And this denominator is just going to be equal to m minus 1, right? So the number of things you pick minus 1. I called it k in my code, so hopefully that doesn't confuse you too much. Because usually it's n choose k. So really quickly, I should talk about how do you actually evaluate this under mod. If it's n choose 2 is just n times n minus 1 divided by 2. That's a common formula. But if you're trying to do this under mod, it might be a bit more tricky. So in general, the formula for n choose k looks like, oh sorry, I'm probably blocking this. That's the formula for n choose 2. In general, the formula for n choose k is equal to n factorial over k factorial times n minus k factorial. The reason for this is if you have a bunch of elements, you have a bunch of things, and you can order them in n factorial different ways. The question is how many different groups of k can be in the beginning. So if like here are the first k things, right, this is k, then we can reorder these things and it doesn't change which things are in the beginning. So there are k factorial ways to reorder this. Well, first of all, there are n factorial ways to order all 6 of them. So that's the n factorial, but we've overcounted when we do that because we can reorder the things in the beginning or the things in the end, and it won't change which things are in the beginning or the end. So there are k factorial ways to reorder the beginning and n minus k factorial ways to reorder the end. So that's where this formula comes from. Yeah, and that's, I guess, why it works. So in order to calculate this under mod, you have to be able to divide. And in order to do division, like this is always an integer, but you can't just calculate it using big integers because like n factorial could be a really big number. So in order to actually calculate this, what I would recommend doing is you can pre-compute factorials and then you can use mod inverse since your mod is prime. Okay, so what is the code for that? Well, I guess we'll go through E1 first. And I store the frequency of each number and also a cumulative sum on that frequency, so I can say how many numbers are in some consecutive range. Then I brute force what this maximum element is, and I brute force like, so this is the maximum value really, and then this to include is like which maximum element is the biggest. Specifically, in this case, to include would be 2, because it would be the second one. But you have to say, okay, what if this is the maximum element, then this one, then this one, and then this one. That's why I have this inner for loop as well. And first I make sure there are at least enough things for me to pick, because I want to pick k of them. So if there aren't enough, then it's not going to work. And then the number of ways for me to pick 2 other things will be the number of things there are, not including this element, choose 2. Because I want to pick 3 total, which means there are 2 other things smaller than me. So n choose 2 on that, and then add that to my total. So this version is pretty much the same. Or for E, this was E1 actually. For E2, it's pretty much the same, I think. Maybe not. Okay, I deleted my code for it. We'll just look at this here then. This code is pretty much the same. The only difference is 1, I'm doing n choose k. 2, I'm doing a bunch of additions under mod, and 3, I do this matrix expo stuff to the power of mod minus 2. So I explain a lot about how to do stuff under mod. If you're confused about that, there's a algorithms thread video that I made on it. It was one of the earlier ones, but it'll be in the algorithms thread series, so you can check that out. And I explain why this mod -2 thing works, why this is the same as dividing. Because initially that seems kind of random and a little bit sketchy, but it turns out, yeah, this is like a very common trick, so you should definitely know this if this isn't something you're familiar with. And then you can do n choose k just using mod inverse in factorials. You can actually do it faster than this. You can do n choose k in order 1 instead of order log, but you don't need to for this problem. Okay, cool. That's E1 and E2. And then last problem is problem F. So this problem I thought was actually quite easy if you are familiar with this sort of thing. But it's a good problem for like learning, I guess. Like it teaches sweeps, and that's a good thing to know. So this is definitely one that you should upsolve if you're not used to it. Okay, so what is the problem? You have, you want to find a group of segments where there's one segment in the group that covers all of them. So obviously, since there's this one special segment, the first thing we should think to do is brute force what that segment is. So I guess in some group we have maybe, yeah, this is fine. So if we look at this segment right here that I've written also in red, that's like a special, or that would make the set special because this overlaps every one of these segments. So this is a special set because it works like this. If you have another segment out here, then it wouldn't be special because this one wouldn't intersect this, and there's no other segment that would make it special. Okay. So yeah, the question is, what is the fewest number of lines you need to remove in order for the set to be special? It's basically the same problem as what's the biggest group you can have that is special? And then the answer is going to be n minus that. Okay, so we have this one very interesting line, which is what we're using because it intersects everything else. So basically what we should instantly think is let's try and brute force what that line is. So what we want to see is for each line, how many other line segments does it intersect? In this case, this one intersects all of them. It intersects 4 more plus itself, so kind of 5. Intersects 5 line segments. So the answer will be the max of what we found for every other line segment and n minus 5. How do we figure this out quickly? Well, here's the idea. We are going to do a line sweep from left to right. So we'll have this imaginary line here. Every time we hit the beginning of some line segment like this, we'll add one, or we'll add a counter right here. So we'll add a counter there. Now we hit the beginning of this line segment here, we'll add one here. Now we hit the beginning of this line segment here, we add one here. Okay, now here we're gonna hit the end of this line segment. So we wanna see how many lines does this line intersect? The answer is just going to be the sum in this range, the sum from the end of the array to everything after this beginning part. And that'll give us the right answer. So yeah, that will include all of the left endpoints that come after this and all of the like other things, because we're only considering line segments that we've seen the left endpoint of. So we want to consider all of the line segments that we intersect the left endpoint of, where its right endpoint isn't too far left for us. So yeah, so that'll consider these 3 left endpoints, and it will only consider right endpoints that aren't like past us. Let me draw a more simple example, and then we can walk through that one just to verify it one more time. So if you have something like this, maybe. There you go, there's an example. So when we see this, we will add a plus here. When we see this, we'll say, okay, what is the sum of this, which is just 1. So there we go. So the answer here is 1. When we see this segment here, see this, we add a plus here. When we see this, we add a plus here. When we see this, we do a range sum here. So the answer here is going to be 2. Then we see this segment here, so we add a plus here. And then we see this here, so we do a range sum in this. There are 3 pluses in this range, so the answer to this segment will be 3. Then we see this here finally, so we query this range here, and this gives us 2. So we take the maximum of all of these, we get 3, and the answer is n minus 3. We have to remove this many, which is equivalent to removing this right here. So there we go, that's the answer. What does the code look like for that? Well, I made a segment class here, so here are my segments. I read in all of the segments at the beginning, like this. So read in the segments. And then I coordinate compress their left and right endpoints, because all you care about is the relative positions of them. You don't care about their absolute values. You don't care about like the absolute value of the distances, just the relative ordering. And I do that so that I can use a Fenwick tree. If you're not familiar with Fenwick trees, Algorithms Live has a fantastic video on it. I would recommend watching that, and it can teach you how to use these, how to be familiar with them. The code for them is right here. You can stop and pause the video if you want to copy my code. Okay, for Fenwick trees. The rest of it you should write yourself. Okay, so then I make a bunch of events. The first event is for when something starts, and the second event is for when something ends. And then I sort them by their relative interest point. Okay, so then for each event, if this is a start event, then I want to add one to the right endpoint. Okay, so that's what this does. I update the right endpoint of the segment by 1. If it's an end event, then I want to consider this segment as some answer. So the number of things it intersects will be the things from the start of that segment to the end of the Fenwick tree. And I can query that here, and then I print n minus whatever I find as the answer. So yeah, that is the solution to problem F. I think that's all. So hopefully that made sense. If you had any questions, I guess feel free to leave them in the comments on any of the problems, and I will try to respond to them. Or you can, I guess, like post on the editorial for the contest. I think would be a good place to ask about them if that comes out soon. I guess this is the Div 3, so they tend to leave the editorial for a while. So maybe on the announcement would work as well if you have particular questions that aren't specific to my video. Yeah, that's all. Hopefully you enjoyed the contest, and if it was rated for you, hopefully your rating went up. And I would definitely consider upsolving these problems, because these are some very classic problems. They're definitely good to know. And if there are any that you didn't get for reasons other than you found them really boring, then definitely work on them, because this, like, getting good at this stuff is important to getting good at harder problems. So I think this was, as far as Div 3 rounds go, I think this was good as a learning material for more new programmers. Okay, that's all. Thank you for watching. Have a great day, and I'll see you. Goodbye.